Hi everyone, this video is why I don't like Rust. So first I want to say that if you like Rust, that's fine. Some people like Haskell, some people like Pascal, some people like Python, some people like C++. It depends on the person, it's just my opinion. And we shouldn't make fun or make a war between each other, so C++ developers are fighting against the Rust developers. We're all programmers, why are we fighting? It's just a preference. So firstly, I'll say what I do like about Rust. First of all is safety. It's a lot safer than, say, C++ or C. It forces you to check errors. The borrow checker I'm completely fine with. I've never actually had problems with the borrow checker, which is probably the most common complaint, I guess, for people trying Rust, is they don't understand the borrow checker. It's not that hard. Well, I basically code that way anyway. Why would you use two mutable references to a thing? I never really had problems with it, so it's not a complaint of mine. I like the basic syntax of semicolons and curly braces. It's similar to C, C++, C#. I don't like the really advanced syntax because I can't really read that, but we'll get into that later. And as I've tried to make compilers myself, I know how ridiculously difficult it is, and the Rust compiler is probably the hardest of all of them. It is insane how difficult it is to make this kind of thing. Not only do you have to track every declared variable, but you have to track when they're created and when they are destroyed, and when you create another reference to them and then delete the old one. This is a ridiculous amount of work, which I'll probably make a future video on, because it's insane how difficult it is to make something like this. Now let's get into why I don't like the language. So my number one problem is, it forces you into a certain style of programming. Here's my general style that I prefer. Number one is, I prefer index-based loops over iterators. It's just a preference I have. I prefer explicit code over hidden magic. I prefer simplicity over complicated abstraction. I prefer languages that don't require you to learn hundreds of different features just to be able to use them at all. I prefer specifying types and hate inferred types. And I prefer procedural programming. So what's the problem? I have just described the opposite of Rust. In Rust, you basically are forced to use iterators most of the time. A lot of the code is based on hidden magic. It's based on macros, like derived macros. It's based on the compiler writing code for you that's generated at compile time. Generally, a lot of things are hidden from you. Rust is based around complicated abstractions, things like tagged unions, traits, macros. You have to learn hundreds of features just to be able to use Rust. Cargo.toml, how do you use dependencies? How do you use a global variable? What's an unsafe block? How do you put stuff on the heap? How many different string types are there? Rust uses inferred types most of the time and almost forces you to use them. In some situations, you literally can't even do it. Rust uses the OOP style of struct with interfaces. They're not called interfaces, but that's what they are. My main language is actually C#, and I've literally never seen the point of ever writing an interface. I don't bother with it. So I don't see the point in ever using traits either. I don't see why you would do this. And then it's based around functional programming. And not necessarily just not having global variables and having functions that have no side effects, but it also uses what I call FunctionCallCeption, where you call about 5 or 6 different functions in a row and chain them. So my main problem is, the way I actually like to code, I can't do in Rust. The language will actively fight me, and everyone who actually codes in Rust will say, "Oh, you're writing it wrong. Why are you writing it like this?" And the comment section will probably be full of this. "Oh, you're writing Rust wrong." I know, that's my problem with the language. I can't write how I want. Thanks for proving my point. So let me give an example of some of the hidden magic inside Rust. So Rust has these things called enums. So they're called enums, but I have no idea why they're called enums, because enums are enumerated values, and they're basically just automated constants for integers. That's all they are. Can an integer hold a generic value like a string or another enum? Not really, it's an integer. Enum stands for enumerated values. They are constants for integers. Rust doesn't have enums. They have tagged unions. It is not an enum, it's a tagged union. Why are you calling it an enum? Here's an example of some code where we're just simulating opening a website, and we're going to use enums, or tagged unions. Now, so here's a very simple example. So we're basically simulating opening a web page and getting an error code. We're just going to open this page. with the URL this page. Of course, we're using inferred types all the time because that's apparently what you're supposed to do in Rust. Even though I hate using inferred types, it doesn't matter. Okay, so we're going to try to open this page. We go to open page, and this returns a result of a string or an HTTP error. An HTTP error is this thing. And then we have this nonsense at the top. What is this? So for some reason, an enum type isn't considered part of the base language. You have to add stuff to it in order to use them. So if you want to print them, you have to put this thing derive for some reason. And this will basically generate some code for you at compile time for some reason. I don't know why this is the case, because enums are pretty important. They're used everywhere in Rust. They're not actually enums, but anyway, they're used everywhere in Rust. They're even basically, if you look at result type, what's result type? Let's have a look. Oh, it's an enum, and it has all these derives on it. Oh, okay. So you have basically your whole language is based around tagged unions, but you have to do this to derive so you can even print them or compare them, or like the basic functionality of an enum should be, can I print it? Can I compare it? What else do I even need? But apparently no. Like, you can use match case, so you can use a match case without deriving anything from it. But everything else, you can't print it, you can't compare it. I mean, just like, why do I need to do this just to print an enum? If I did this in Zig, all right, let's do this in Zig. So we've done exactly the same thing. And you can just, okay, you set it to this. Okay, we can compare it, and we can print it innately. Why do I need to have the compiler generate stuff when it should be inbuilt in the language? It's like if I create an integer like this, you know what I can do with this number? I can compare it. Look at this, equals 10. Oh, look, do I need to derive something from this? Oh, should I do this? Derive something like this? No, because no one would use this language if you had to do that for every integer you created. But for some reason, people tolerate it for enums. Let me compare it. Let me print it by default, because that's what you do with it anyway. I mean, basically every enum is going to have debug, derive debug, derive debug. Like, oh. Are you seeing my frustration yet? Right. And then, okay, so we're basically just going to simulate stuff. So if it's example, we're just going to say page content here, return a string. And yeah, just to confuse you, yeah, so result type is an enum itself, a tagged union. So result type is a tagged union, and we're putting in our own tagged union into another tagged union, if that makes sense. So we can have a tagged union with a tagged union inside the tagged union, and then inside that, we're going to have another tagged union. Okay, we're gonna use this tagged union to use the error code of this tagged union within this side inside this tagged union. This is just over-engineered, unnecessarily complicated. And then I have to use match case. Let me show you how I would actually want to code this. Alright, so then we run it, and it just says trying to open page example.com admin, error 401 unauthorized. Alright, so I've created an actual enum. What an actual enum is, it's a constant that represents a number. They can't hold strings. They can't hold other tagged unions. So I've just created this for myself, given them values, and then have this HTTP result to string so I can print them. That's all I need to do. And then I have this page data just to hold the data and the code. Then I just return that. So I could make it an optional, like this. But what's an optional? Oh, it's another tagged union. Oh, okay. Do I really want to use tagged unions everywhere? It's tagged unions all the way down. No, I don't. I'm just going to give it a not any value. Just not any, and then see if it's not any, or just use the error code. And then I just have an I32 error code, which is again represents this. And then we just literally just set the content if it's that, or we set the code and then just return page data. That's pretty much it. And then we just print it. I don't have to use a match case. I can compare it. Look, I can compare it by default. Oh, I didn't have to use derive and have the compiler generate loads of code for me. For some reason, I needed to do this when I just want to compare it. You can't, why can't I just compare it? Here I can also print it using HTTP result to string, and it prints. And this basically prints out exactly the same thing as before. It's just a lot less difficult to make for me, and I know I don't need to understand there's a tagged union inside a tagged union. With this, I don't have to use a match case. I can simply just say, if it's that, then just print it. This is just easier for me. But apparently, oh, I'm not following the style guide. You should use tagged union. I don't want to use tagged union, sorry. It's overcomplicated. I don't need to. So just to drive my point home, if I wanted to create the exact same thing in Zig as we did in the original Rust code, I would have to do this, which is what? Oh, it's a union. Oh, so it's not an enum. No, it's a tagged union. That's what they are. If you want them to hold values, they're tagged unions. Stop calling them enums. They're not that. So another problem with Rust is the fact that regular enums that are just integer types are also the same types as tagged unions. For some reason they're treated as the same thing, but that means we need to use derive on both of them for some reason. One is very complicated, a tagged union. They use generics, so you have to work out on compile time what they are and generate the code. Whereas regular enums are just integers. Why can't you just hard code them and just print them? Like it's simple. It should be very simple to compare them. They're just integers. And it's very easy to print them as well. You don't need all this complication just for enums. Another problem is that in the standard library, they have all of these derives. So every time you use an optional type or a result type, it will have to print out all of this. So let's say, for example, we have... So if you do, for example, a result type with a string and an IO error, it will generate this kind of code. Quite a lot. 70 lines, 70, 80 lines. So let's say, for example, you create 100 of these in your project. Something like this. Well, so 70 lines of code for each derived function to be generated, and you have 100 of them. That's 7,000 lines of code the compiler has to generate. And that's just the result type. Also for option type, any enum you make, it will have to generate the same code for each derive. And you wonder why compile time is slow in Rust. Right, so I was coding in C++, and I generally hate header files, which I can make another video about if people want to know why. And I thought maybe I could make some project that will automate header files for me. So I thought, oh, why not try Rust? You know, I'll give it a go. I'll give it a fair try. So I got an LLM to generate something that will basically loop through a directory and then find all the files of that with CPP extension. And it gave me this code, which I call FunctionCallCeption, where instead of going inside a dream, inside a dream, inside a dream, inside a dream, you go inside a function call, inside a function call, inside a function call, inside a function call, inside a function call for entry, which it doesn't even tell you. You can't even so it's a directory entry. Can I do this? Can I do this? No. No. Why can't I do that? Inferred types are better, apparently. I can't even write the type. Okay, so thanks, Rust. I have to hover over all the time. So we have new, which is a function, and this chains to into iter, so we're converting it into an iterator. And iterators are very complicated in Rust, really. They're basically a struct that implements the trait, an interface, of next, whatever that means. I don't really understand it. It's too complicated for me. Again, people are going to say skill issue, but I prefer simplicity. This is not simple. So we convert it to an iterator, okay. Then we have a filter map result okay. I don't even know what this means. I guess result is like if it's not an error. So we convert it to an iterator and we make sure it's not an error. And then we filter that with E in this, whatever this means. E.fileType. Is it a file? And is it a E.path.extension.map or 3 function calls in a row? Ext for extension equals CPP. And then out of that, I don't even know. Okay, so what I'm going to do, I'm going to show you how complicated this is. First of all, how do I even reason through this? Like, first I need an iterator, then I need a filter map, then I need a filter, then I need what are these types? What are they returning? What if there's a bug? How do I debug it? Good luck. Good luck is the answer. So what I tried to do was actually separate this into sections and give it types. So I'll show you what I did. So first we have entry iterator is a walk directory into iter. There is also an into iter in the actual standard library. So this is a walk directory into iter. And that goes war directory new folder path dot into iter. So we have an into iter, which is a struct which has all this stuff, and it implements the trait. Again, we got this derive stuff. It implements the trait of next. Rust isn't too complicated, right? Anyway, so it's an iterator that can somehow convert what I want into files. Somehow, somewhere, I don't know, it's hidden magic. Then we get an entry filter map, which is a filter map of into iter, fn return or fn result directory entry walk directory error, and this returns an optional directory entry. It's not too complicated, Rust, right? Because I definitely know what a filter map into iter fn. I don't even understand what the type is. And then we get to the creme de la creme of this. So this is a filter map. But here's the best thing. Let's try to copy this, shall we? Let's try to. We want to specify the type, right? We want to specify the type. So let's specify the type. Let's do this. Specify the type. And it's okay. It's giving me errors. Why is it giving me errors? Cannot find type filter in this scope. So wait, what's filter? Anyway, the errors aside, fixing the errors aside, it's literally impossible to write the type here. Why? Because it's generated at compile time. You don't actually know what the type is until the compiler actually writes the code. So you literally cannot write the type. This is hidden magic. Like, the compiler literally generates this at compile time. There's no way you can even write the type, no matter what you do. So it's just hidden magic. What's the type? It's filter map into iterator fn result directory entry error, and it returns an optional directory entry. Implement fn mute at directory entry. What?
But why? Why would you do that? Why would you do any of that?
I just want to look through a directory. Is Einstein expected to understand this code? And then here. So we have for entry in, so you can't even specify the type. So after, I have to specify the type after, so I can actually write the type. Otherwise I can't write it. So I have to actually, create a copy of it, let end directory entry, and then, okay, then I can specify the type here. Like, why? And of course, and then we have more FunctionCallCeption at the end. We stdfs read to string path.expect, which will just crash if it, doesn't find that. And then we have content.chars.toTake.collect FunctionCallCeption. So here is how I wrote this code. Alright, so we have a directory entry in entries. Again, this is kind of using magic because entries itself is a redirectory. And if I go to a redirectory, where's the actual, the stuff you can input? Is it an array? Is it a list? Is it a box? Or how do I use the index? You literally are forced to use iterators, which I don't like. I want to use loops with the index, but apparently I can't do that. I am forced to use an iterator. And then I can't specify the type again. I can't specify the type with something here. No, I've got to do it after. I've got to copy the variable to actually specify the type. I say, oh, don't specify the type. It's smaller. I want to understand the code, especially when I don't know what the error type is. And the best thing is when I hover over this, it just says error. What's error? What's that? It's an stdio error. And what's an stdio error? It's a struct with a rip. What's rip? It's just over-engineered, right? Anyway, so we go over that. We get the entry, which I find this really weird, to be honest. I generally don't like match cases or stuff like this. Anyway, so if there's an error, we do this. Otherwise, we basically get the path, which is a path buff, which is again another struct, which has an OS string apparently. Anyway, then we recursively call this function if it's a folder. Otherwise, we process CPP file. Notice how I haven't used FunctionCallCeption, and I've specified every type here. We just display this. We read the string, and then we pass the file. And pass the file uses a lot of other stuff. Anyway, this is how I like to write stuff, and Rust actively fights me the whole time, which is my problem with it. If I try to write stuff like this, people say, oh, that's not how you write Rust. What are you doing? writing how I want to write code. So my general complaints about Rust aren't anything to do with safety or the borrow checker. It's generally just, it's over-engineered, overly complicated, and I can't write the way I want to. That's my main problem with it. So I don't find it enjoyable to write in, and the language actively fights me when I try to. So there are some other problems I've found while using Rust, which I'll show now. So I made a video comparing languages in a chess move generator to test performance. And I ran across a very, very annoying problem in Rust, which was stack overflows. So in chess engines you use massive constants for bishop and rook moves. It's the fastest way to get those kind of moves. You just use giant constants. So I tried running this in debug mode and it would give me a stack overflow. We don't even need the chess code to actually show this. So this is literally all the code we need. So we have a 200,000 sized array, and we literally just get one entry out of that and then return it and then print it. That's literally all we're doing. Have a guess what's going to happen. So just to prove it, let's go version, Rust version 1.9. So this is the latest version of Rust. And we're going to go cargo run. Oh, we got stack overflow. Strange. Okay, let's run it in release mode. What? Basically, the problem is that in debug mode, it will put constants on the stack and give you a stack overflow if they're too big. This is supposed to be a language. Like, this should never happen. Like, it doesn't matter. Like, this, it should never happen. It should run in debug mode and release mode. They should both run. This makes no sense at all. Why? Plus, you increase the stack size. It shouldn't be on the stack. It's a constant. It should be in global space. What is wrong with it? So you're able to write the most complicated compiler that can track when variables are created and when they're destroyed and when they're referenced somewhere else and then delete the old one. You can do all that, but you can't put constants on the global space and not give a stack overflow? Come on. And you could argue, oh, this is LLVM. Rust converts to LLVM. Maybe it's LLVM's fault. C++ and Zig both convert to LLVM. I'll convert this to Zig and show you it will run in both modes. Let me run this in Zig. Let's go Zig run main.zig. Oh, look, it run. No stack overflow. Okay, let's run it in release mode. -O, release fast. Oh, look, it runs. They both convert to LLVM. This is a Rust problem. Right, so here's the basic chess engine code. It's just we have constants in the global space, and we just have run perft, and perft inline is this massive function that just generates moves, plays them all. That's all it does. We're using global variables because that's what I found was the fastest. I tried putting in the struct into the function, and it was actually slower, or just slightly slower, but I couldn't get the performance any higher than what I got. So someone, I'll probably put his name on the screen, on GitHub, basically made the code a lot better, well, a lot faster. And what did he do? Did he change the code? Not really. Let's have a look. So first we have engine, just all the structs, basically one struct, and then we implement engine and put all the functions inside methods, inside struct, and somehow it was 40% faster. What? So it makes no sense. I mean, you could say, oh, it's LLVM. No, it's not LLVM, because Zig has exactly the same thing, where you could put them in methods of a struct, or you could put them in just, procedurally in global space functions, and just pass a struct to them, or use global variables. The performance would be basically similar or the same. Really, there's not much difference. 40%? What is wrong with this compiler? So if you use procedural code and just use functions, it's 40% slower? What is this? Anyway, that's my thoughts on Rust. It's generally just not for me. It's not my kind of language. Most things are just overly complicated. And my main complaint is the fact that I can't code the way I want to, and the language actively fights me if I do, and other Rust users will say I'm coding it wrong. So I'll go code in another language then, and not do it wrong. Of course, if you like Rust, that's fine. Go code in it. I don't think it's a bad language. It works. It's just not for me. It was also ridiculously difficult to make with the compiler. Anyway, that's all for this video. Thanks for watching. See you guys next time.